Welcome to Rationals for Pre-Calculus of Math 11. Today we're taking a look at solving rational equations, which is section 7.5 for us. You know what? Solving rational equations is pretty well the same as just adding and subtracting or combining rational expressions. It's just now there's an equal sign, so it's not really a big deal. When we solve a rational expression, we can eliminate the fractions by multiplying both sides of the equation by the lowest common denominator. So before, when we would add or subtract rational expressions, what we would do is we would multiply by 1. We would multiply by the lowest common denominator divided by the lowest common denominator. What we're doing here is we can get away with just multiplying both sides of the equation by the lowest common denominator, because as long as we do it to both sides of the equation, it's still the same. That's algebra for you. The steps here we see on the right: identify the non-permissible values. You know what, that's just kind of that standard thing we're going to be doing here a lot with rational expressions. Determine the common denominator and multiply both sides of the equation by it. Okay, so lowest common denominator again. Numerically, I see that there's there's a 3 and a 6, so the lowest common denominator is 6. For the variables, I need an x as well. And I need to solve by multiplying both sides of the equation by this. So let me just put kind of big brackets, 2 over x minus 1/3, and I'm going to multiply that by 6x. And I'm going to multiply 6x times the other side, which is 5 over 6x. So on the left-hand side, solve the equation. Let's distribute that 6x times 2. And let me just write it kind of with a dot in between for now. It's usually a good idea to leave it kind of factored like that, because you can see some good cancellation. That's supposed to be a dot, not a subtraction sign. Means multiplication. Let's do some canceling. I certainly have an x and an x canceling there. That's good. We know that it's working if we get rid of all the denominators. And a 6x and a 6x cancel. So all the denominators are gone. That's really the key part here. If you still have denominator, you know you've made a bit of a mistake. And we get 12 minus 2x equals 5. And let's subtract 12 to get negative 7. And divide by negative 2 gives me 7 halves. So 7 halves is my answer. I think our last step here is just check the solutions against the restrictions, the non-permissible value. So our non-permissible value for this was x couldn't equal 0. I got x equals 7 halves. Probably works out pretty good. So a fairly straightforward technique. I think these seem to be a little bit easier problems than, say, what we were doing last class. It's just now we have to make sure that we multiply by both sides by the lowest common denominator. Why don't you hit pause here and see if you can do this question B. So x can't equal 0. Lowest common denominator is just plain x squared. On the left hand side we have 3 plus 10 over x, and I'm going to multiply that by x squared. And on the right hand side here I'm going to go x squared times 8 over x squared. So again, we see some cancellation. Sorry, let me expand maybe first. 3x squared on the left plus x squared times 10 over x equals x squared times 8 over x squared. This is where again we get the cancellation. X squareds cancel. The x and one of the x's cancel. So we get 3x squared plus 10x equaling 8. This looks like a quadratic. We are going to have to solve that either by factoring or the quadratic formula. In this case, I think this factors 3x. Lots of factoring this year. 3x, that should be 4, and 2 would work out, and I want that to be negative 2 and positive 4. So 3 times 4 is positive 12 minus 2x, and we get x equals 2/3 and negative 4 as solutions. And again, check that against the restrictions that we have, in this case that x can't equal 0. So getting maybe a little bit more complex here. If you want to try this one, go ahead. I see that m can't equal plus or minus 1. That's basically from that difference of squares, m squared minus 1. And we have m plus 1. So the lowest common denominator here is m plus 1, m minus 1, which is really a difference of squares. So let's go m plus 1, m minus 1 times negative 1 minus 3m over m squared minus 1. And on the left-hand side, sorry, the right-hand side, m plus 1, m minus 1 times m over m plus 1. Let's take a look at cancellation here. M plus 1's cancel, that's good. M plus 1, m minus 1, that's a difference of squares, which matches the difference of squares in the denominator there. So we should have negative 1 minus 3m on the left, and on the right side, m squared minus m. Let's group everything again. This looks like a quadratic. Let's group everything to the right-hand side. M squared plus 2m plus 1. And does this factor? Yeah, m plus 1. M plus 1 works out. And we get solutions that m equals negative 1. Now, take a look at the restrictions here. M equaling positive or negative 1. Here we have m equals negative 1 is the only answer that works. So what we're going to write down here is no solution, because it does not match, it doesn't get past our restriction of m equaling plus or minus 1. So, there's an interesting one. Last one here. Looks like a little bit more factoring involved. Why don't you give this one another try, and we'll go from there. So, let's maybe start by factoring this, just so we can see what the lowest common denominator is. We have x over x plus 4. It's that right-hand side I'm really worried about. That's that x plus 3, it looks like it factors into, an x plus 4. So we get the restrictions that x can't equal negative 3 and negative 4, and that's great. Easy to pick off the lowest common denominator here. That's, again, that x plus 3, x plus 4. So if we multiply everything by x plus 3, x plus 4, I have that times 2x over x plus 3. I have minus x over x plus 4. And this right-hand side actually works out to be nice and easy because that's actually the denominator already, so that will cancel. So we have cancellation right away. Let me get rid of that just so I don't have to write it again. We have the x plus 3, x plus 4. I'm going to distribute that. This whole chunk of stuff is going to multiply by both terms. So that's going to be by 2x over x plus 3, as well as x over x plus 4. And it equals 6. So again, we get some cancellation here. The x plus 4's cancel. The x plus 3's cancel. 2x times x plus 4 is 2x squared plus 8x. That's good. We have minus x times x is x squared. Minus 3 times x is negative 3x. So I'm not going to go back. I'm going to remind you about when you're subtracting off binomials, you have to make sure that you distribute that negative sign. And that equals 6. So 2x squared minus x squared is x squared. 8x minus 3x is positive 5x. And if we subtract a 6, it should equal 0. So, does this factor? Let's see, we have x equaling 0. I think a positive 6 and a negative 1 should work. And we get solutions of 1 and negative 6. Again, check those against our restrictions, which were just negative 3, negative 4. I think we're doing all right. So, you know what? Solving rational equations, probably not so bad. Maybe even a little bit easier than the adding and subtracting binomial and trinomial denominators. So Really, multiply by that lowest common denominator, check restrictions, pretty straightforward steps. This ends the notes for solving rational equations, section 7.5.